Hi guys, sorry that I'm not in today. My kids are sick right now, so I am home with them. So I am making this video for you so that we can still have our test on Friday before the break. Okay, so feel free to pause the video to go through the examples for the do now. I'm just going to jump right in. So 57 and 58 both refer to the casino game of craps. They're telling it's based on rolling 2 dice. Then they give you the probability model below. Okay, so the most common bet in craps is the pass line. A pass line bettor wins immediately if they roll a 7 or an 11. This is called a natural. What is the probability that a natural does not occur? Okay, so in this one, when you're doing it, just make sure that you pay attention to the words. So a 7 or an 11, that would be the 6 out of 36 and the 2 out of 36. So the chances of getting the natural would be 8 out of 36. So if we want not the natural, we want to do 1 minus 8 out of 36, which will just give us 28 out of 36, which is choice E. Okay, and in number 58, if a player rolls a 2, 3, or 12, it's called craps. What's the probability of getting craps? So remember, that means all of these guys, or an even sum on one roll of the dice. So if anything, you guys are learning how to gamble in this course, huh? All right, so we have 2, 3, and 12. That would be called craps. So we have here's 2, here's 3, and here's 12. Or they say if it's even, so if we want an even sum, then that would be the 2, the 4, the 6, the 8, 10, and 12. Okay, for this one, I'm not going to set up the addition rule. I'm just going to look at the table logically. So if I do craps 2, 3, or 12, I have 1, 2, oops, what am I doing? Yeah, 1, 2, and 12. So that's going to give me 4 out of 36. And then plus, what haven't I counted already? So I don't want to count the 2 again for the even. So now I'm going to add the 3, the 5, the 5, the 3, and I'm not going to double count the 12. So when I add all the evens that haven't been added already, that will give me 16 out of 36, which comes out to be 20 out of 36. So choice C. Okay. All right, today what you're going to be doing as you watch the video, and feel free to pause, rewind, fast forward, whatever you need to do to get through it. But it's called Bayes' law, and this is one of the tougher concepts of the unit. So maybe good that it's on video so you can rewatch it if you get stuck on it. But definitely make sure that you take notes on what I'm going through with you. All right, so Bayes' law. Basically, Bayes' law is a way to helps us find reverse conditionals. And the way that you're going to do this is by making a tree diagram. Okay, so on this page, we're just going to go over general, and then we'll jump into an example and see it put to use. So consider events A and B. All right, create a tree diagram. So we have 2 events that are occurring, A and then B. So whether that is, flipping a coin and then spinning a spinner, like we have 2 things going on. So the way that we're going to create our tree diagram is first event A is going to happen or it's not going to happen. So that will give me 2 branches on my tree diagram. Either A occurs or it doesn't occur. Then we go over to our second event. Well, if A occurs, then B could occur or B could not occur. If A does not occur, then B can occur or B could not occur. Okay, so just very generally written out right now. All right, so now when we go to do Bayes' law, we're going to be putting probabilities on this tree diagram. So there's going to be numbers placed on all of our branches to represent the different probabilities, okay? So what will go on this first one will just represent the probability of A occurring, which if it's 40%, we'll put like a 0.40 here. And then not A occurring would be something like 0.60. So when the numbers go in, that's where we'll put them. But for now, I'm just writing it generally. So this is the probability that A does not occur, the complement. Okay. All right, now this branch is a little bit trickier because what's happening is that we already know that A occurred. So now how would we write the probability of this branch over here? So it's not A and B occurring. What this is this is the probability that B occurs given that A has already occurred. So this is actually a conditional probability already loaded, okay? So then if we look at this tree branch, what this is going to be is it's going to be the probability that B does not occur given that A already occurred. So try to write the next two branches on your own, trying to make sense of it. And then I'm writing it too if you paused it or didn't pause it. Okay, so then my last one is that B did not occur given that A did not occur. Okay, so those are all conditional branches. All right, now that's the idea behind Bayes' law, but there is one more level to it. So often we will want to know what the probability of A and B occurring are going to be. So I'm going to go and I'm going to show you how you can get this. So let's take this one right here. The probability of B given A. Let's just solve that one out, okay? So I'm going to go down here and let's recall that if we have the probability of B given A, and we write that with our conditional statement like that's on the reference sheet, the conditional law, then that just means that you're doing the probability of B and A, which is the same thing as A and B, it doesn't matter what order you write it in, over the probability of, and when it's a conditional, you write it over your second letter. Okay, so don't get that confused with the independence test. So now, if I want to know what is the probability of B and A, I could put this over here over 1 if I'd like, and cross multiply to start solving for, well, what would that give me? Well, that would then turn into 1 times the probability of B and A, which is still just probability of B and A. And then you multiply, cross multiply here, and you get the probability of A times the probability of B given A. Okay? So that's just using one of our laws that's on the reference sheet. So if we go up here to our tree diagram, pay attention to what we have here. The probability of B and A, which is the same thing as A and B, is equal to, and then we have the probability of A, which is right here in our branch, and the probability of B given A, which is what we have right here. Okay? So if we want to figure out what the probability of A and B is, we could take whatever probability is on this branch, probability of A, and multiply it by whatever probability is on this branch, the B given A. Okay? So you don't have to solve that out and see that over and over, that the same thing will happen if I want to know what's the probability of A and B complement. Right? I'm going to take the same branches and just multiply them, but now using this conditional. Okay? So if you're looking for the and statement, what you're going to do is you're just going to multiply the branches' probabilities that it takes to get you to both of them. Okay? So this would be the probability of A times the probability of B complement given A. All right? The two branches leading to the and. Okay? All right, so just to finish this off, this is, again, it's all in very general speaking with A and B not representing anything. All right, so what do I want for this one? So the probability of A complement and B would be equal to the probability of A complement times the probability of B given A complement. And then this last one would be the probability of A complement and B complement is equal to the probability of A complement times the probability of B complement given A complement. Okay? So that pattern goes the whole way through. This times this will give me that. Okay, those are the two parts over here. All right, so the tree diagram doesn't have and right away, but you can get the and. All right, so let's see it being put into action. I'm going to do two examples with you. So the first one's over on page 378, number 83, and it says first serve. So we have tennis great Andy Murray made 60% of his first serves in a recent season. All right, so I already know that anytime they give me a percent, that's going to be something to pay attention to. So he made 60% of his first serves in a recent season. When Murray made his first serve, he won 76% of the points. When Murray missed his first serve and had to serve again, he won only 54% of the points. So he missed the first serve, serves again, and he gets only 54% of those points. All right, suppose you randomly choose a point on which Murray served. You get distracted before seeing his serve, but you look up in time to see that he did win the point. What's the probability that he missed the first serve? Okay. So this is not a question that you can do with logic. This is this perfect setting for a Bayes law, okay, where we make a tree diagram. So first off, we have a couple things going on in this one. We have some variables. So we're talking about whether or not he makes the first serve and whether or not he wins the point. So I am going to use M as representing that he will make the first serve. Let's start off identifying our variables. And if he doesn't make the first serve, we're not going to say like something different. We're going to say M complement, trying to limit our variables. So does not make the first serve. So he does or he doesn't. Does not make first serve. Okay. The other thing that we're worried about or working with here is whether or not he wins the point. So I am going to make P represent he wins the point. And then P complement will be does not win the point. Okay, so now I want to take all of this in yellow and now turn it into probability statements. So if you want to pause and try to do that on your own and then check it with me, I'm just going to keep going. So he made 60% of his first serves in a recent season. So the probability that he makes his first serve is 0.60. I can also then get the probability that he doesn't make the first serve with that because he's either making it or not making it, but that one's not spelled out, okay? What else? It says when Murray made his first serve, he won 76% of the points. Okay, so when he made his first serve, that's a hidden conditional, all right? He won 76% of the points that time. So I'm going to write that out as the probability that he made his first serve. That's the condition. That's what we know. So that was a hidden conditional. When he makes the first serve, that's the given that. He wins the point 76% of the time, so I'm going to write 0.76. Okay, when he missed the first serve, again, there's that hidden conditional. He has to serve again, and then he wins the point only 54% of the time. So I'm going to write that the given that is that he did not make the first serve, so MC. And then the way that he gets the point is 0.54. Okay. So when you're reading through and you're setting up that you have all of this right here, you have two conditionals and then a probability, because those were the ones that were spelled out. That right there should trigger that you are going to do Bayes' law tree diagram. Right? The only way to go through and do a question like this is to make a tree diagram. You can't answer what they're asking just from logic and thinking on your own. All right, so what are they asking? It says, suppose you randomly choose a point on which Murray served. You get distracted before seeing his first serve, but you look up in time to see that he did win the point. What's the probability that he missed the first serve? That is a hidden conditional as well. So what we do know is that he is going to get the point, okay? So we see that Murray did win the point. What's the probability that he missed the first serve? So what we're out to find here, the question is, We do know he won the point, but what are the chances that he missed the first serve? That's our question mark, okay? So MC given P. Now that's the reverse of this over here, but conditionals are not commutative. The way that you write them in order, that is important, okay? So we will need to set up our tree diagram, and that's what I'm going to do now. So on the first branch, I'm going to say whether or not he makes the first serve. So M for makes the first serve, MC for missing the first serve. We know that that has a probability of 0.60, and I already said that that's 0.40, but these two branches should always sum to 1, okay? So when you're doing a tree diagram with Bayes' law, that going down should make a 1. Okay, now we know that he's either going to make the first serve and get the point or not get the point. He's either going to miss the first serve and get the point or not get the point. Okay? So now if we go back to what we were saying before, this probability represents that he gets the point given that he made the first serve. This branch represents the probability that he doesn't get the point given that he made the first serve. This is the probability that he makes the point given that he missed the first serve. And this is the probability that he misses the point given that he missed the first serve. Okay, so writing it out like that. You don't need to write that out, but it might be helpful when you're filling in. Because what else did they give us? Well, they did give us two conditionals. They gave us P given M, and P given M is this probability right here. So I'm going to put the 0.76 above that. If that is 0.76, then that is going to make this branch 0.24, because these two also need to sum to 1. Okay? And then what else do we have? We have P given MC. So P given MC is right here. So if I know that that is 0.54, we'll put that on this branch. And then these as well need to sum to 1. So then that is going to give me a 0.46 over here. Okay? Now, getting to back to the question, like we are going to have to find a few things, but before I even do that, I want to write out something that I know that we're going to need anyway, which is getting the and statements. So that's what we were just showing, is how the tree diagram works, so that we can just jump right into it. So if I need the probability that he makes the point and, or sorry, makes the first serve and gets the point, I can't use the 0.60 and the 0.76 individually. I have to multiply them. And we just showed on the previous screen why we're allowed to. You don't have to go through and show why that happens. It just, now we know it happens. Okay? So I have the numbers written out here. I'm just going to complete the tree diagram if you want to try to pause it and do it yourself. If I want the probability that he makes the first serve and misses the point, then that is just going to be the two numbers leading up to that, which is the 0.60 and the 0.24. So 0.60 times 0.24, which will give me 0.144. Then this will be the probability that we have he misses the first serve and gets the point, which is 0.40 times 0.54, which is 0.216. And then finally, the probability that he misses the first serve and doesn't get the point as well, 0.40 times 0.46, which is 0.184. Okay. All right, so there's my complete tree diagram. Now I'm ready to go and see what it is I need from this tree diagram. So remember, our question is asking us this right here. What is the probability that he gets the point, that he missed the first serve given that he got the point? All right, so let me come down here. The probability of MC given P, expand that, always expand that. So that's just the probability of MC and P over the probability of P. All right, so MC and P. Well, let's see. In our tree diagram, MC and P is just this right here. So that's going to be my numerator. That's 0.216. But the denominator is a little bit trickier than what you may think, because they're talking about what's the probability that he gets the point. Well, he could have gotten the point either making the first serve or missing the first serve. There's two avenues to get the point here. So this part over here is really saying that you want to do the probability that he makes the first serve and gets the point, or misses the first serve and gets the point. So really that's 0.216 over, and then we already have those two probabilities calculated out, which is a good idea to do before you start answering the question. So that's going to be 0.456 plus 0.216, which will give me 0.216 over 0.672. And we never leave decimals in our fractions, so 216 out of 672 is fine. Or if you want to turn that into a percent, I think it's about 32.1% of the time, okay? So that would be the answer to the question finally. All right, these are big questions. This is one of the hardest things from the unit. I'm sorry I'm doing it in a video, but like I said, you can come back and rewatch or replay that if I lost you in there. All right, if you're good, I'm going to go on to the next one. And if you're not, then rewind. Okay, this next one, and then you'll have some time to work on your own and make sure that you got it. So this is number 81. It's called Filler Up. So in this one, we have in a certain month, 88% of automobile drivers filled their vehicles with regular gasoline. All right, so they're throwing percents. That's important. 2% got mid-grade, and then we have 10% getting premium. Okay, so there's a lot happening already. Of those who bought the regular gas, 28% paid with a credit card, and customers who got mid-grade and premium, 34% and 42% respectively, paid with a credit card. Okay, so because they mentioned, what was it, the mid-grade first, that's the 34%, and the premium second, that's the 42%. Okay, so we're talking about credit card payments with the type of gas that they're getting. Suppose we select a customer at random, draw a tree diagram, find the probability, and then they give us one last thing. Okay. All right. So this right here, if we're taking a look at everything that they give us, we have not just an event that has an A or a complement. In this one, we're dealing with the types of gas. And so when we're dealing with the regular, mid-grade, and premium, we can't use complements. So I'm going to say that P is going to be premium gas. M is going to be mid-grade. And then, what was the first one? Regular. Duh. Okay, so that's not a scenario where we can use complements. We do need three variables. The other thing that we're looking at is whether or not they paid with a credit card. So I'm just going to make C that they pay with a credit card. And in this one, we do have a complement scenario where we can say not pay with a credit card. So I don't know, maybe it was cash or Apple Pay, but all we care about is that it's a credit card or not a credit card. All right, so now let's start writing down some of these probabilities and get out of the paragraph and into symbolic notation. So 88% of automobile drivers fill their gas with regular gas. So the probability that we're getting regular gas is 0.88. The probability that we're getting mid-grade gas is 2%, which is 0.02. Don't write 0.2. And then 10% are getting premium, so I'm going to write P of P is equal to 0.10. All right, so that sums to 100. That's the types of gas that they're selling. Now, they tell us of those, so remember, of is a hidden conditional. Of those who got regular, that's our given that. So we know that they got regular gas. So the probability that we know that they got regular gas, 28% paid with a credit card. So credit card given that they got regular gas, so 0.28. Then they also gave us the mid-grade and premium, that those who got those types of gas that paid with a credit card. So paid with a credit card given that they got mid-grade is going to be 0.34, and probability that they paid with a credit card given that they got premium was 0.42. Okay, so we have all of that handed to us in that paragraph. As soon as you see a bunch of conditional probabilities, that is going to be a scenario for Bayes' law. Okay, So part A, they're breaking this one up for us nicely. So part A says make the tree diagram. So when I go to make my tree diagram, the first event is what type of gas are they getting? They're getting regular gas, mid-grade, or premium. And it doesn't matter if you write it in a different order, just your numbers have to match up in the end. So if you wrote P first, doesn't matter. All right, and when they get their gas, they're either paying with a card or they're not paying with a card. If they got mid-grade, they can pay with a card, or they don't pay with a card. And then finally, premium, same thing. Okay, so we have all of our branches coming together over here. All right, now when we go to make our tree diagram, we should have the probabilities on there. So we know already that regular is 0.88. We know that mid-grade is 0.02. And then we know that premium is 0.10. All right, and if it helps you to write this out, then write this out. This branch represents that they're paying with a credit card given that they got regular. Okay, this is that they don't pay with a credit card given that they got regular, and then so on and so forth. So do that if it helps you see where to put the numbers better. I'm just filling them in. Credit card given they got premium. Not a credit card given premium. Okay. All right, now what do I have up here? So we have credit card given that they got regular. So credit card given they got regular, what was it, 0.28? If that's 0.28, then that makes this 0.72, because again, their branch has to sum to 1. Then we have credit card given that it was mid-grade, that's going to be 0.34. So then this is going to make this 0.66. And then finally, the last one's 0.42. And then this is going to be 0.58. Okay. Now, I'm going to continue with my tree diagram. That's really the tree, but this is always a helpful thing to have, especially because this is where we're always going with Bayes' law, is to now do the and. So what's the probability that they got regular gas and they paid with a credit card? That's going to be our 0.88 times our 0.28. And then you can calculate all the numbers. So pause the video and do the calculations to fill in this part, okay? Okay, now something I didn't say before is that another check that you could do is that all of these numbers will also sum to 1. So that's another thing that happens in the tree diagram. All right, so if we go back to that one from before, this column here sums to 1. Okay. All right, back to what we have over here. So that's B. That's, I'm sorry, just kidding. That's A. Part B now wants us to find the probability that a customer paid with a credit card. All right, so it's breaking this down for us. We just want to know what the credit card people are. So part B, if you're paying with a credit card, the probability that you paid with a credit card, there's 3 different avenues. Here's a credit card here, so they could have gotten regular and paid with a credit card. They could have gotten mid-grade and paid with a credit card, or they could have gotten premium and paid with a credit card. So if I write that out, then I'm going to say regular and credit card plus mid-grade and credit card plus premium and credit card, which we have all those numbers already calculated because we just kind of did all that ahead of time. So that will give us our 0.2464 plus 0.0068 plus 0.042, which will give us a grand total of 0.2952. Okay, so about 29.52% are paying with a credit card. I would think that would be higher, but that's okay. All right, part C. Finally, here we have suppose that the chosen customer paid with a credit card. All right, suppose hidden conditional. So we know that they're paying with their credit card. What's the probability that the customer bought premium gas? Okay, they're not saying what's the probability that they bought premium gas. They gave us that. There were 10% of them there. They're saying that we know that they paid with a credit card. So that's a conditional broken up over two parts. So the way that you want to write that out symbolically is that we know that they're paying with a credit card. So what is the probability that they got premium gas? So premium gas given that they paid with a credit card. Next up, expand it. So that means do P and C over the probability of C. Use your reference sheet because it does tell you bottom number. All right, we know that P and C, if we look at our tree diagram, is right here. That's the probability of paying with a credit card and premium. So that's 0.042. And then I'll put that over. Now this is where this one was nice. They had us find the probability that they paid with a credit card up in part B. So I don't have to go through and do that again. That's 0.2952. And then if you turn that into a fraction without decimals, that can just be 420 over 2952. Or if you want to turn that into a decimal, that's 0.1423 or percent. You guys know how probability works at this point, okay? And that would be the chances that we chose someone at random, that if we knew they paid with a credit card, what's the chances that they got premium gas, okay? Now, again, Bayes' law is helping us find reverse conditionals. So even though up here they gave us the probability of C given P, that is not the same thing as P given C. So reverse conditionals do need a lot of thought, and the tree diagram breaks it up for us. Okay? So I have a homework assignment uploaded for you to complete as well. One is going to be making a tree diagram similar to this. And then the other is, I think the tree diagram's already listed. So try that out, and then tomorrow we'll go over that homework. All right, I hope you guys have a great day. Bye-bye.